Good morning to all. I am Dr.Neel Kamal, Associate Professor, School of Engineering and Technology, Electrical Department, IIMT University, Meerut. So in the continuation of my lecture, this is my third lecture on transformer, single phase transformer. Today I am taking single phase auto transformer. So let us start with some contents. These are the contents. First of all, introduction of single phase auto transformer, its construction and copper saving in auto transformer, power transformer in auto transformer, power transfer and voltage rating of auto transformer, advantage, limitation and applications of single phase auto transformer. So first of all, let us start. What is a auto transformer? If we compare auto transformer with the conventional transformer, or we can say two winding transformer, in which we are looking here, in two winding transformer you are having two different winding, one is this and second is this. One winding in which we are applying the voltage and where we applied the load, this is known as the secondary winding. But in case of single phase auto transformer, we have only single winding. We have only the single winding in which both winding exist, primary winding and secondary winding. Where we are applying the supply, this is known as the primary side, and after taking a tape, when we apply a load here, this is known as the secondary winding. So we can say this is the primary winding part N1 and this is the secondary winding part, we can say N2. So first of all, this is very clear that two winding transformer have two different winding, one is this and second is this, but in case of single phase auto transformer, it has only a single winding among these two. So this is the case of auto transformer. Now general concept of auto transformer: in single phase auto transformer, one single winding is used as a primary winding as well as secondary winding, but in two winding transformer, two different windings are used for primary and secondary purpose. So a circuit diagram of auto transformer in which current distribution and voltage distribution has been shown here. Let us start with primary current I1 here, and after this taking part, just a minute, this part we are having the current distribution I2 here, and remaining current in BC part is I1 minus I2. So this is about the current distribution of single phase auto transformer step down type. We are having two type of transformer here, auto transformer. One is step up transformer and second is step down auto transformer. Auto transformer in which voltage distribution is like that, voltage per turn, this is the primary voltage V1 and having the number of turns N1 here. So obviously voltage per turn in this winding will be V1 upon N1. V1 upon N1 means voltage per turn, we can say. Voltage per turn is V1 upon N1. As we go on the secondary side where N2 is the secondary winding, so if we multiply V1 upon N1, that is the voltage per turn, to the secondary turn, we can get the voltage at secondary voltage. So V1 upon N1 multiplied by N2 is the V2. Obviously N2 upon N1 is known as the turn ratio, K. It is denoted by K. This is the turn ratio. So V2 upon V1 is equal to K, or we can say that V2 is equal to K V1. V2 is equal to K V1. So this is the voltage distribution in case of single phase auto transformer. Obviously, we have a single winding in case of auto transformer if we compare with the two winding transformer, or we can say conventional transformer. So obviously there will be the saving in winding material, or we can say saving of copper metal, but we can also it prove by some derivation part, like we can derive this expression to show the copper saving in auto transformer. So let us start. First of all, what is N1 I1 and N2 I2? Starting from here, auto transformer, if we compare to the conventional two winding transformer, in both type of winding, weight of copper mainly depend on its length as well as the cross sectional area, because weight is proportional to the volume, and volume have the two terms, area and thickness, we can say. So proportional to the cross sectional area, we can say, saving in copper. So when we see the AC part here, because winding has distributed in two part, one part is AC and one part is AC, and second part is BC part. So in AC part current remains I1, but what is the number of turns here? Total number of turns here is N1. But in BC part, total number of turns is N2. So in AC part, the total number of turns remains N1 minus N2. Here in from A to C part, the number of turns remains N1 minus N2. So if N1 minus N2 multiply by the I1, because current is going in AC part I1, so the weight of copper in AC section, that will be proportional to N1 minus N2 multiply by I1. And similarly for BC part, in BC part number of turns remains N2 here, and what is the current here in BC part? Current is I2 minus I1 or I1 minus I2, depending upon the direction you are taking here. So we can say N2 I2 minus I1, that is the weight of copper in section BC, that is proportional to N2 and multiply by current I2 minus I1. Hence total weight of copper in the winding of auto transformer, by adding these two, N1 minus N2 I1 plus N2 I2 minus I1. If we add both these, we will get finally, because we open the bracket here, so N1 I1 here minus N2 I1 plus N2 I2 minus N2 I1 here. So N1 I1 minus N2 I1 plus N2 I2 minus N2 I1, and we also known as N1 I1 is equal to N2 I2. MMF, or we can say ampere turns, remain same in both directions. So N1 I1 is equal to N2 I2. So after this we can conclude 2 N1 I1 minus 2 N2 I1, and finally we can say 2 N1 I1 minus N2 I2. This is the weight of copper in entire section, that is proportional to twice N1 I1 minus N2 winding and N2 I1. Similarly, if we compare with two winding transformer where N1 is the number of turns in primary side and N2 is the number of turns in secondary side, so definitely weight of copper is proportional to the sum of these two different windings. One is primary winding and second is secondary winding, so obviously that will be proportional to N1I1 plus N2I2. So because we know N1I1 is equal to N2I2, so we can taking both similar part and we can say 2N1I1 minus 2N1I1. Now if we compare by taking a ratio, in the previous case we have said WA, that is the weight of copper in auto transformer case, and WTW means weight of copper in two winding transformer. If we compare by taking these two equations, that is 2N1I1 minus N2I1 upon 2N1I1. So after this we can say N1I1 minus N2, because 2 is cancel out here, so N1I1 minus N2I1 upon N1I1, and this is the similar case, so we can say 1 minus N2I1 upon N1I1, and I1 also cancel out here, so we can say 1 minus N2 upon N1, and N2 upon N1 is the turn ratio, we can say N2 upon N1 is the turn ratio. So simply WA upon WTW will be equal to 1 minus K, and after this we can say WA is equal to WTW bracket start 1 minus K. So this is the weight of auto transformer with comparison of two winding transformer, two winding single phase transformer. So what will be the saving overall? Saving means if we subtract from the weight of two winding transformer, or we can say WTW minus WA, that is the saving of copper. WTW minus WA, weight of copper in two winding transformer minus weight of auto transformer weight. So that is the saving, that is equal to K multiplied by WTW, and we know K is less than 1, so we can say saving is equal to K multiplied by the weight of two winding transformer of copper. So in this way we can prove there will be definitely saving in copper material in case of auto transformer as compared to two winding transformer. Now in the similar case of copper saving, we can say we can also compare power transformer in auto transformer. So power input to the auto transformer get transferred to the secondary by two ways. One is the electromagnetic induction and second by the conduction system. We can easily compare these two. I have taken the case of two winding transformer here, and this is the case of single phase auto transformer here. In the single phase two winding transformer, or we can say the conventional transformer, we are basically having the two windings here. One is the primary side and second is the secondary side, and these windings are not electrically connected. These two windings are not electrically connected because these are insulated in this core. Among this core, this winding is insulated, so there is no electrical connection in these two windings. So total flux will confined by the mutual induction system, but in case of single phase auto transformer, we are having only the single winding means primary and secondary have the similar case of turn, not in the different direction. So we can say in this case conduction will be occur here and electromagnetic induction, or we can say mutually induction, both system will take place. So we can say power transformer in auto transformer will be by two system. One is electromagnetic system and second is the by conduction system. And we know the voltage in primary side is V1 here and current in this side is I1 here, in the just like in the previous case we can say. So input power will be V1 I1 and output power will be V2 multiplied by I2. This is the output power or power in secondary side, we can say. So power transfer inductively, that is equal to I2 minus I1 multiplied by V2, and that is equal to V2 I2 minus V2 I1. And if we replace this V2 by V1 by using the formula, simply V2 is equal to KV1, just like that. So if we replace all these secondary voltage with this formula, we can easily obtain power transfer is equal to 1 minus K multiplied by the input power. So definitely for the same excitation, voltage and winding currents, the auto transformer gives output power much more than two winding transformer. Hence we can say auto transformer have comparatively, as compared to two winding transformer, better efficiency. Auto transformer have higher efficiency as compared to two winding transformer. So next, voltage and current ampere rating, voltage current rating जो होती है, so we can say VA rating of auto transformer. In primary side we can say V1 I1, and in secondary side we can say V2 I2. That is the VA rating of transformer. And in similar case we compare with two winding transformer. Then in case of two winding transformer, V1 minus V2 I1 is equal to I2 minus I1 into V2. And by opening this system, V1 minus V2 I1 is equal to V1 I1 minus V2 I2, and we know V2 is equal to KV1. So in case of two winding transformer, volt ampere rating is equal to V1 I1 minus KV1 I1 by replacing this V2 from KV1, and finally we will get 1 minus K VA AT. AT stand for auto transformer volt ampere rating. So in this case we can easily seen by this derivation, volt ampere rating in case of auto transformer is equal to 1 upon 1 minus K multiplied by the volt ampere rating of two winding transformer. We know this is the case of step down transformer. So in this case K is less than 1. When K is less than 1, definitely 1 minus K is also less than 1, and finally we will get volt ampere rating of auto transformer is higher than volt ampere rating of two winding transformer. So this is the key result about this. Auto transformer is step up or step down, it doesn't matter. Volt ampere rating is always more than the corresponding two winding transformer. Now what are the advantages of auto transformer, what are the disadvantages of auto transformer, and finally what are the applications of transformer, we will discuss here. Saving is appreciable when ratio of transformer is low, that is lower than 2. N2 upon N1 is less than 2, then it is better. Auto transformer is smaller in size and cheaper, this is again advantage. And auto transformer has higher efficiency. We have recently derived this expression about the efficiency, and this is because less ohmic losses and core loss due to reduction of transformer material, because single phase auto transformer is using the single winding instead of two winding, so definitely there will be less copper losses, and so efficiency will be higher. Auto transformer has better regulation, better voltage regulation as compared to two winding transformer, as voltage drop in resistance and reactance of single winding is less as compared to two winding transformer. But it also have disadvantage One, due to smaller leakage flux whenever between windings, impedance is low. This results in severe short circuit currents and under fault condition, because winding is single winding means leakage flux will be less and short circuit chances will be comparatively more and more here in this case. So this is the disadvantage of auto transformer. And no electrical separation between primary and secondary, which is risky in case of high voltage levels, because winding is same. We have distributed in primary side and in secondary side, but even winding is similar, same winding is here. So this is also a risk here. That is why we are saying no electrical separation between primary and secondary winding, which is risky in case of high voltage level particularly, and economical only where the voltage ratio is less than 2, otherwise it will be comparatively costly. And the usage of single phase auto transformer or applications of auto transformer, we can say auto transformer with a number of tapings are used for starting induction motor and synchronous motor, because in such cases where we required very smooth variation of voltage we required. In case of two winding transformer, or we can say the tape changing transformer, we are having the voltage tapes in terms of like 5 volt, 10 volt, 15 volt, 20 volt, 25 like that. But in case of auto transformer, we can vary the value of voltage even of the single voltage, 1 volt. So auto transformer in case of induction motor and synchronous motor starting, that is very good application, and this is known as the variac here. Second, it can be used to vary the voltage to the load smoothly from 0 to rated voltage. Such device giving smooth and continuous supply using an auto transformer. This is known as the variac. This is the best application of single phase transformer we are using here in laboratories for different practicals and in the starting of induction motor and synchronous motor like. Finally, we can compare single phase auto transformer to the two winding transformer. So we will discuss one by one here. First of all, definition. By the definition we can say having only one winding as a part which act as primary and other act as secondary. But in conventional transformer, or we can say two winding transformer, it is a static machine in which transform electrical energy from one end to another end, and second, number of windings. So number of winding in case of auto transformer we are using a single winding system here, but in two winding transformer we are having the two separate windings. This is the difference. Now insulation. What about the insulation? The primary and secondary windings are not electrically insulated. In case of auto transformer, primary and secondary windings are not electrically insulated, but in case of two winding transformer, primary and secondary windings are electrically insulated, and only system of power transformer is mutual induction. But in case of auto transformer, we earlier have discussed that in two way the power has been transferred here. One is as the induction system and second is the conduction system. Next, size. In case of auto transformer, it is comparatively having less size, and conventional transformer has bigger size. Power transformer, partly by transformation and partly by direct electrical connection, but in case of two winding transformer, through transformation only. Voltage regulation is better in case of auto transformer and good enough in two winding transformer. Winding material less required because less copper material required, we earlier have discussed, and drive also saving of copper materials, so more required in case of conventional type transformer. And what about the circuit? The primary and secondary winding circuit and connected magnetically. Circuit connected magnetically. But in case of two winding transformer, primary and secondary winding circuits are connected both electrically and magnetically. Economical case, auto transformer is somehow more economical as compared to conventional type or two winding transformer. And what about the efficiency? And just we have discussed about this. Auto transformer has more efficiency as compared to two winding transformer. Leakage flux and resistance is low in case of single phase auto transformer as compared to two winding transformer, in which leakage flux is comparatively higher. Cost cheap, and in case of two winding transformer it is costlier. Losses we earlier had discussed. Copper loss is very low as compared to two winding transformer because it has the single winding system. Applications we have just discussed, used as a starter in induction motors, as a voltage regulator in railways or in the laboratory system. But in case of two winding transformer, we are using the power system for step up or step down of voltages. So we have discussed about all about the single phase auto transformer. In our next class we will discuss about the three phase transformer. So thank you very much. Have a nice day. Thank you.